grade teacher at Cherrington Elementary, and this morning the entire 5th grade class is going to Skype with a couple of physicists over in Belgium who study the sun, and it's going to be fantastic.
Your thoughts about this project?
I'm really excited about this project because I haven't really talked to a scientist ever in my life, so I'm really excited. I'm not really nervous at all because I used to be in like ballet, so I'm kind of happy about this.
Do you have a question prepared?
Yes.
Awesome. Okay, well, good luck today.
I'm Nissa, and I'm going to have to say, how do black holes form?
Oh, so your question is how do black holes form? So tell me a little bit about this project and your feelings about what's about to happen.
It's going to be great. I hope it goes well.
Are you excited?
Yeah.
Cool. Have you ever got to talk to a real scientist?
Hello.
Hi. How are you? Hi guys. Okay. Can you guys see?
We can see you. Okay, we can't hear you that well.
You can't hear us?
Not you yourself, though. I'm Dr. Seaton.
And I'm Dr. Rackmiller.
And we're here at the Royal Observatory of Belgium, in Europe. And we work on a satellite called Proba 2. And Proba 2 is a little tiny satellite. I think maybe you already know this, but the size of a washing machine. Just give me a second. Here we go. All right. So now you should be able to see yourselves. Yeah? Okay. So I'm going to go over here. So now, hopefully you can see that little, we have our Proba 2 website. And it's just a website like any other website. And we have a picture of our satellite here. Can you guys see my mouse pointer?
Yes.
Okay, so I'm pointing to the satellite. This is what our satellite looks like. I think I sent you a picture of it already. And actually, when we work with our satellite, we use our website, just like this. We just use a website like any other website. And that's what allows us to talk to the satellite, to check and make sure the satellite is healthy and working the way we expect it to work. So I'm going to show you that now. So the first thing I'm going to show you is, this is kind of a really complicated window with lots of information. And each line in this sort of complicated table tells us about a particular process that's happening either on the satellite or on the ground to check on the data, to check on how the satellite's working. And so there's a guy who sits across the hall, and his job is to watch this all the time and to make sure that none of the lines turn red. So if a line turns red, can you see the red line here?
Yes.
Yes.
Yeah. If a line turns red, that means something happened on the satellite that we don't want. Or it means something happened in sort of getting the data from the satellite.
The satellite, where to point? So do we want the sun in the center, or do we actually want to move it so the sun is on the side of our image? So these are some of the things we tell the satellite to do on a regular basis.
And now that we're talking about this, I've loaded up the sort of place where we have all the instructions for the satellite. And I don't know how clear it is on your screen controller, and there's lots of other information that it's not that interesting, I won't show you. One thing we can do is we can monitor lots of different things on the satellite. We can monitor, for instance, where is the satellite around the Earth at any given time. We can monitor what is the temperature of our instruments. And so this graph is a place. The sun. And we can look at that. So I thought you might be interested to see what's happening on the sun today. Yeah?
Yeah.
Okay. So this is actually a graph. It goes back to the 10th of February, which is yesterday. And it shows what's happening on the sun. Each one of these little lines, we haven't done that yet. But we can definitely see that over here, you see there's different lines. All these lines are telling us about how bright the sun is at different wavelengths of light. And they all go up over here. You guys see where the bump is? Let me zoom in on it so you can maybe see it a little more clearly. And I think I can make a line. Yeah, so maybe you can see there's a big, on the satellite time, satellite uses its own times. 4 o'clock in the morning would have been 11 o'clock last night for you guys in Ohio. But there was actually actually there was a solar flare, and so we can look and see this just happened on the sun a few hours ago. And what we can do now is we can actually go and say, okay, well, there's a solar flare, so let's see what happened on the sun. So let me show you what happened on the sun. This is actually a picture of the sun. Can you see it okay? It's black and white?
Yes.
Yeah. So this is a picture of the sun today. It's actually a movie. It goes from midnight until, which midnight on the satellite is -5. It's 7 o'clock your time yesterday, 7 o'clock p.m. Until you see it. But if you look in the sort of middle of the sun here, you'll notice there's a lot of like sort of little things getting bright and dark and moving around. And now it's let me play it again. So we're going to play it again. Can you guys see that there are like little things moving around there? Yeah. I'm going to move the movie here to about the time of the solar flare. And I can tell you, I don't know if you can see there's like a white blob right here where my mouse pointer is.
Yeah.
It's a little small. Maybe I can make it a little bit bigger. I don't know that I can. I think it's full size. Anyway, it's a little small, but there was a little tiny solar flare right in the middle of the sun, 4 o'clock this morning. And this is the kind of thing we watch for. We like to watch for these flares. We can predict then if a solar flare like this happens, maybe people on Earth have to expect some effects from the flare to happen in, I don't know, 3 days, something like that. It usually takes about 3 days for a little flare to reach us on Earth, because the sun is really, really far away. Yeah, so you actually are lucky you got to see a solar flare just today, just this morning, and it wasn't a real big one, I can tell, because there's a little, the big ones cover like the whole sun. But it's something that we, that's kind of what we watch for, and for people on Earth, this one probably doesn't matter, but maybe for people who have like a satellite in space, they have to be a little prepared to deal with the effects of it. Maybe we can talk a little bit about that later on. I know you guys are interested in hearing about how solar flares can affect us on Earth, so we'll come back to that. Do you have any questions about what I've said so far?
You're not going to get a headache, nothing like that happens, okay? But what can happen is you have these little bits of material that have a lot of energy. So they come towards the Earth, and especially the technology that's not down at the surface of the Earth, like satellites that are orbiting in space. You have these really high energy things that can hit them, and so it can damage the satellites. And generally, that doesn't have a lot of influence on you, but it's expensive, because these things are very expensive technologies.
Billions of dollars.
Billions of dollars. So when these satellites go bad because of something hitting them, then that's not so good for the government.
It's a little like when a solar flare hits a satellite, it's a little bit like the satellite got hit by lightning. It's not quite the same, but it's basically, you can imagine like what lightning would do with it, like, hit your computer would not be happy. It's kind of the same thing.
Yeah, exactly. So you can have satellites that are high energy things that come and they have collisions with the particles in the atmosphere.
And that protects us on the ground.
It does.
From all this sort of radiation that comes out of the sun when there's a solar flare. So we're safe on the ground.
We're safe. So the two things that protect us are the magnetic field and the atmosphere, what we breathe.
So a solar flare can have an effect on us on Earth, but not an effect on health or on people on the ground.
Yeah, it's not individual people. The things that are affected are large government things. So satellites. Sometimes you can have a power outage, right? So sometimes that can happen, and then the electric company is in kind of a panic to try and turn it back on so that everybody can have the energy that they usually use for their lights, for their computer, for their TVs, things like that.
It can interfere with radio and television broadcasts, so it could cause you not to be able to hear your radio so well. Although that's only a concern for like people. That's a really good question. It's a really complicated question.
Yep.
It might be useful. I know somebody asked about
think they were aliens for real life? I mean, like, should they be in real life? Okay, thanks, Tim.
What?
What was the second one?
Should they be in real life? I mean, like, aliens should be in real life?
Yeah, just read your
Could aliens be in real life?
Yeah.
Yeah, well, I think that's a really good question. It's a question a lot of scientists are thinking about every day. In fact, it's such an important question that there's a whole field in science that we call astrobiology. So it's like biology, like the study of life. Like, there's biologists who study like frogs, and there's biologists who study like fish, and there's biologists who study plants. Well, there's a whole group of biologists who study the possibility that there's actually life off the planet. And this is what I always tell people when they ask me, because it's not a question that has a simple answer, like all of these questions. In our galaxy is sort of the region of space where we live, where the Earth is, where the sun is, where all the planets are. There are 400 billion stars. 400 billion stars, that's a lot of stars, okay? Like, $400 billion, that's like, you can think about it, you'd be very rich if you had $400 billion. Well, 400 billion stars, we are very rich in stars in our galaxy. And in the universe, there are 100 billion galaxies. So each one of those galaxies has about the same amount of stars as ours does. And so if you add all the stars in the whole universe, there are 300 sextillion stars. That's a really big number. That number is so big, I didn't know what 300 sextillion meant. No. So I did a little bit of math, and I worked out that if you had 300 sextillion...
Signals from the stars to try and find music, to try and find a message that somebody else might be sending to us.
Does that answer your question? Yeah?
Yeah.
Okay, perfect. Thanks. Emily, do you want to ask your question?
Why is it that the sun has so many different temperatures at the same time?
Did you hear?
The temperatures, yeah. Why does the sun have so many different temperatures? I thought all of your questions, we got them by email so we could do some research, because we really had to think about these questions. They were all really good questions, because I got them, and I'm a scientist who studies the sun, and I had to sit down and say, why does the sun have so many temperatures? That's not so easy to answer.
That's actually, of the questions that you asked us, that's probably one of the hardest questions out there. And one of the things we want to tell you is that as a scientist, that doesn't mean that we know all the answers
for sure.
to specific things. Our job as a scientist is actually to ask questions that don't have answers to them, and to find answers, and to think that we have come up with the answers. But just because we come up with an answer that we think is right, that doesn't always mean that it is right. This is a constant, our entire careers are based on asking a question and looking for the answer to a question.
So this is one of those questions that scientists haven't fully answered yet. So this is what I would say. We live on Earth. And the Earth is kind of one planet, it's in space, but if you think about the Earth, if you live in, you guys live in... Yeah, that's another thing that scientists are really studying. So you guys might not know, but it wasn't that long ago that I was sitting in a classroom like your classroom. Yeah. And when I was in the classroom, we only knew about a few planets, and all of those planets were in our solar system. You probably learned with Mercury and Venus and Earth and Mars and Jupiter. Those were all the planets that anybody knew about.
And when we were kids, Pluto was also a planet.
Oh.
Now we have much better telescopes. We've looked at many stars very carefully, and we've discovered, does anybody know how many planets we've discovered outside of our solar system?
20? 12.
12?
58.
A lot more than 12.
58. Okay. 2,000.
Yeah, it's between 1,000 and 2,000.